Hi, I'm Christopher, a research software engineer with Research Software Workshops, and it's a very warm welcome to part 10 of Git for Collaboration. The link to the material is at the bottom, and if you go to the repository best practice section, you'll reach this page. So now we're going to talk about repository best practice, so how best to sort of organize the files within your GitHub repo. This is going to be more of a talking session, it's like sort of ideas and things. So what best practice for a repository is depends really on who is working together in the repository and what they're doing. So at a minimum, I'd say it's worth having the following in the repo. I'd say you should have a good README file, so readme.md. GitHub will render the markdown into a nice page, and that readme.md should say what the repository is for and just give some information about the background of the project, just so people can quickly see what is it, what's being stored here, who is it for, etc. I think you should also have something like maybe a good contributors file or some way of listing who are the main people who are contributing to this project. This maybe should say who is working together, possibly expected rules of behavior. So which role do people have? Who is the person who controls when things are accepted? Pull requests are accepted into the repo or in charge of communication or things like that. And indeed, if the project is big enough, and I think even for quite small projects, it's worth having a good code of conduct. And so I've got a little link here. Here we have a code of conduct link, and this is just a help from GitHub about how you could choose a code of conduct from a template and how you could basically add one to your project. It's worth doing. Let people know the ground rules for how they're going to work together. And then the third thing every repo should have is some form of branching or some other mechanism that separates the live day-to-day development of the project from the releases or the sort of the finalized outputs. So then somebody who's coming to the repo kind of fresh and just wants to download a working version can just go to a release or a finalized version, and development is happening somewhere else, and they don't get confused about things that are sort of half created. Now, in terms of how you create the branches and how you divide them up, we have a few strategies that could be useful, and they go up in complexity, and also they're more appropriate. Sort of, they start off for small projects, and then they become more appropriate as you go towards larger projects. So for branching strategy 1, that's really about how you would split up your main branch into a main and devel. So typically when you start a GitHub repo or any Git repo, you have one branch called main, and everything is happening in main. This is fine for small projects, but when you get moving towards larger projects, you really do want this separation between properly released versions or pretty much fully working code and day-to-day development code. And so it's a good idea to create a branch called devel or development that is the one that you use for the day-to-day development of your project. In this way, your main branch is then just sort of reserved for the finalized and released versions. And then a good workflow that you could put together would be to make a release of your project, of your software, for example, by issuing a pull request from devel into main, and then only accepting that pull request when you're satisfied that the release is ready, everything is working, everything is ready to go. And that way, it's set up that every single sort of pull request that's accepted into main is a release, and day-to-day development happens in devel. And indeed, if you set up this kind of workflow, then you could add a GitHub action that's triggered only on pull requests into main, and that action would do the work of building new packages, creating the documents, building a new website, and deploying the actual piece of software. And if you do this, where your software is being deployed continuously whenever you pull a request into main, then that's sometimes called continuous deployment or CD. And so you might hear people talk about CI/CD, continuous integration for the testing, continuous deployment for we're making the new versions when we accept a pull request into main. Now the next strategy that's worth doing is to use feature branches. So when you start collaborating on a project, there will be this temptation that you'll give every single collaborator their own branch or their own fork of the project. And the rationale behind this will be that you want to let everybody work in their own space, and if they have their own branch or their own fork, they're not going to tread on each other's toes, and you'll minimize conflict or day-to-day merging issues. Now, unfortunately, following this kind of user branch way of setting up branches is not really very successful. What happens if you follow this is you end up separating your collaborators out into their own branches, and then they will rarely actually ever communicate because they won't need to. This means they'll be working independently, they'll be creating lots of conflicts, but they won't know about that. And this means that it will defer all of the issues that are related to conflicts and all of the problems that will come with a merge right to the point where you have to make a release, so the final release stage of the project. And then some poor person will have to say, okay, I've got these 5 user branches, I'm now going to try and merge them all together into one release. And it's basically a Herculean and probably impossible thing to do. As well as having the problem with, you have this very difficult release schedule if everyone has their own user branch. What you also find is that using user branches means that the people developing themselves actually get personally, emotionally attached to their version of the project, to their branch. Because the individual collaborators become emotionally attached to their branch and their additions, this means that decisions to merge code or delete code or resolving of any forms of conflict get mixed up with emotion. So individuals will end up trying to defend their own work that they've been working really hard on, and then trying to get rid of other people's work. So they value their own stuff over others' work. And so you end up with these very heated merge meetings because, people have worked hard on their branch. They really don't want it to be, in their words, vandalized to make it merged into somebody else's branch. Now, user branches are not a good idea. It also means the merges take a long time, and you may not merge until you have a release, and so the merges might happen only once every 6 months, which is way too long to go between merging. So a solution to using user branches is to instead use feature branches, and we do have a little link which tries and defines them in more detail here. So it's like a little note of reflection, how feature branches came about and some information about them. Now, a feature branch is a short-lived branch in the repository that is used to add specific features to the project. So if you think about what we were doing with our super project to make the kitchen, you could imagine having a feature oven branch where you would work on the plans to add the oven to the kitchen. There could be a feature cupboards branch where you plan installing the cupboards. And of course, a feature kitty litter branch to plan, Thompson's space within the kitchen for his kitty litter. Now, ideally, the features will be complementary. So you wouldn't have a feature gas oven and a feature electric oven both in the same project. They're going to be clashing with each other. And also, ideally, you would set the features up so that as they're being implemented, they won't impact each other. So, they don't depend on each other, so different people can work on these different features relatively independently. So, for example, someone can be working on feature oven while somebody else is working on feature cupboards, while somebody else is working on feature kitty litter. They don't depend on each other. Now, if there are any dependencies between these features, then you can then use communications, for example, using GitHub issues, and the planning and the milestones to begin to decide the order in which the features should be implemented, and then to divide the work that needs to be performed as needed between everybody in the group. Now, once the feature is completed, so I finished planning the kitty litter, for example, then you would issue a pull request from that feature branch to pull that code back into the devel branch. Now, it's the responsibility of the owner of the feature branch to merge the changes from devel and to make sure that this feature meets any project requirements. So it may be that you require that all features must come with tests. They must match a format specification. They must require that all GitHub actions check the code have been run and passed. So it's the responsibility of the feature branch owner to make sure that's all done before they then issue the pull request into devel. Once they issue the pull request, the project manager, the person who has the authority to accept pull requests into devel, will then review the pull request, possibly give a code review to the code in the feature branch, and they'll basically check to make sure everything is kind of okay. And if everything looks okay, they will accept the pull request, and then they'll delete the feature branch at the end. Now, in this way, the devel branch will advance feature by feature, and the project team will be always communicating with each other about what features are needed and how each individual feature can be implemented. And then the work is divided between those features, so the people work on different features at different times and they work efficiently. This way of working basically separates out the user and their emotional attachment to their code, and everyone begins then thinking of the common goal of all the features that need implementing in this project, and then they're divided between the people in the team. It's a very nice way of working. And of course, because you only accept pull requests into devel for features that have been fully tested, they have passed all of the requirements of the feature, this means your devel branch always has valid and sane code. It's always tested. If it was a piece of software, maybe all of the tests have always passed and the binaries that you've auto-generated can be installable. And what this means is every commit, every pull request accepted into devel is a valid and working version of the software. And so actually making a release is just a simple task of issuing the pull request from devel into main. So it's almost like you're just marking this version in devel. This is now going to be our 2021.1 release or our 1.6 release. And voila, it's been very, very easy to create. So it really does reduce the emotion and the attachment that can be had to code that causes conflict. And the entire process really encourages you to communicate and work as a team efficiently together. Now for the final strategy, this is a slightly more advanced thing, but one of the issues about the pull request when you make it is the pull request will basically contain all of the changes that were made in the feature branch, but separated out into each of the individual commits made in that branch. So if you remember the feature branches we saw earlier when we were merging in from feature Cat's Corner, it was like 6 or 7 different commits. Now, this is good because it does preserve all of the commit messages and the history of how that feature branch was developed, but it can make reviewing the changes in the pull request difficult. So for example, one team member might be committing code very frequently, and so their feature branch will have like 100 commits in it for like a single pull request, while another team member might be committing daily, and so their feature branch, the pull request from that might only have like 2 or 3 commits. If both of these very different styles of committing were merged into the repository, you'd find that maybe when you scan back through the history to find out when things were changed or what was happening, it could look very inconsistent and very messy. Equally, when you're reviewing the change, you really just want to see one commit that explains what the change is and all of the changes in one place. You don't want to have to cycle through 10, 15, 20, 100 different commits to do the code review. And so what some projects require, or they suggest, is that you squash all of the changes that are made into one big change. So it's almost like you're merging all of those changes together into one change, and then it's that one change which is given as the pull request. And that way it can be reviewed and it will exist as a single entity. The merge would then pull in this single change with one single overarching commit message that will summarize the entire change and why it was merged. And so in this way, you'd find devel would then just have a small number of commits, with each individual commit being the squashed large number of commits that were made from each of the real individual commits from each feature branch. Now this squashed merge is called rebasing. The git rebase command will perform the squashed merge. So basically, you can see how it works here. And literally, the git rebase command, where do we have it? Here we are, git rebase master will just basically pull in everything to master. And this is doing a git merge as we would normally do. This is done automatically, but when you do a git, when you do a pull request, this takes all of the individual commits. Now, as I said, by doing squashed or rebasing squashed merges, you do lose the history because you've lost the individual commits and the individual commit messages that have all been squashed together into one big commit with one overall messages. So there is some controversy over it. So some people like it and they require it. Other people say, no, you should not do this. So you can find little articles, again, you can look for many of them, and say rebase versus merge, which is better. People will argue about this. But regardless of what you use, one of the kind of overarching best practices is that you've made the decision. So, you follow the guidelines, the the code style, the project style of the repository. You don't do your own thing, and that's really one of the best pieces of advice when it comes to collaboration. Is you work in the style and the behavior of the group, and then no one can actually tell when you look at the code who wrote what, and then you all feel collective sense of ownership over the whole thing. And so follow code styles. If this is a rebasing repository, use rebasing. If it's a merging repository, use merging. And all work together for a common end goal, not for your bit that you think is great. So of course that's the end of this section. It was a talky section, but if you click next, you'll move on to the summary and conclusion of this workshop, and I look forward to seeing you there.